Having seen the demo in action, let's now discuss how you can set up this environment yourself for hands-on practice. For Windows users, here's the straightforward process to get started. The fundamental design principle of this lab is that everything runs inside the Docker container. This containerization approach provides several critical advantages. You get an identical, consistent environment regardless of whether you're running Windows, Mac, or Linux. Docker isolates the lab environment from your host system, preventing any conflicts with the existing software or configurations. You will need two prerequisites installed on your system. First, Docker Desktop must be installed and running. You can download it from docker.com. Docker Desktop includes everything you need for container management on Windows. Second, you will need Git Bash installed. Git Bash provides a Unix-like terminal environment on Windows, allowing you to run Bash scripts. The execution process involves three simple steps. First, open Git Bash and clone the repository by running git clone. And second, navigate into the project directory. Third, ensure Docker Desktop is running, then execute the startup script. The script also provides several additional command options for different scenarios. If you've previously run the demo and want to reconnect to an existing tmux session, use just start sdn docker.shell file attach. And then for Linux and Ubuntu users, the setup process is even more streamlined. The prerequisites are similar to Windows. But however, the only thing you have to do is just execute the shell file directly instead of using Docker. When you run the startup script, the environment opens in a tmux session. For those unfamiliar with tmux, it's a terminal multiplexer that allows you to manage multiple terminal panels within a single window. This is incredibly useful for our SDN lab because we need to monitor the control and interact with the network simultaneously. The screen configuration is straightforward. The display is divided vertically into two panels. The upper panel shows the view controller logs, and lower panel provides the Mininet CLI. You only need to learn a handful of keyboard shortcuts to navigate effectively. To reconnect to existing session after closing your terminal, use the command tmux attach -t sdn demo. To move between panels, press Ctrl B followed by the up arrow to move to the upper panel or down arrow to move to the lower panel. If this is your first time using tmux, don't feel overwhelmed. You can accomplish everything needed for this lab by remembering just 3 or 4 of these shortcuts. Let's examine what's actually inside the Docker container that makes this lab work. The container includes 4 core software components, each playing a crucial role. First is Mininet version 2.3, which is a network emulation platform. Mininet creates virtual switches, hosts, and links that behave like real network equipment. The remarkable thing about Mininet is that it can create an entire multi-node network topology on a single machine using lightweight virtualization technique. Second is Open vSwitch version 2.17, which provides the virtual switches used in our network. Open vSwitch is a production-grade multi-layer virtual switch that fully supports the OpenFlow protocol. Third is View Controller version 4.34, our SDN controller framework. Vue is written in Python and provides a comprehensive implementation of the OpenFlow protocol. Fourth is, of course, Python version 3.8 or higher. Now let's take a closer look at the Python packages installed inside the container. We have 6 core dependencies that are essential for the lab to function. First is Vue, and second is Eventlet, an asynchronous networking library. This specific version enables Vue to handle potential thousands of OpenFlow messages concurrently. Third, NetworkX version 3.1 is used to represent the network topology as a mathematical graph, where switches are nodes and links are edges. This enables the Dijkstra algorithm to find the shortest path. Fourth is MSGPEC, which handles binary serializations. And fifth is Oslo.config, used for configuration management. Lastly, OVS version 2.17 provides Python bindings for Open vSwitch. For anyone who doesn't yet have Docker installed, here's a quick guide to get you set up. You can just follow up the following steps, and also you can refer to the following website. Now we are reaching the most technically detailed part of our presentation, the implementation section. Let's start by understanding the project overall architecture and how files are organized.